and maximize. Perfect. All right. So decimals allow us to kind of look at numbers. How do I want to say this here? I think there's a better way of saying it. There is a relationship between a fraction and a decimal. For example, 1/2 is equal to 0.5. All right? 1/3 is equal to 0.3, and that little bar above the 3 means repeating. All right? And we use decimals everywhere. Okay, one of the ones that we're exposed to the most, one of the ways that we use a decimal the most is with money. For example, a bottle of water could be $1.25. Now, that 0.25 is a decimal representation of a certain fraction. In this case, that certain fraction is 25 over 100. Now, where this really kicks in is if I give this 25 over 100 names. For example, we know that there are 100 pennies in $1. However, if you have 25 of them, you have 1/4 of a dollar. If you think about it, you have 1/4 of a dollar. Okay? So the decimal, what it really helps us to do is kind of look at fractions in a different light. All right? Now, before we go any further, we need to kind of understand place values and stuff like that. So we know that if I were just to write out a number, that would be the ones position. This would be the tens position. This is the hundreds, and this is just a whole number. Hundreds, thousands, and then everything repeats. If I keep going to the left, you got 10,000s, 100,000s, and then millions, 10 millions, and so forth. The decimal is always on the far right-hand side of any whole number. So even though I may write the number 4, I can write that as 4.0. In fact, I can write it as 4.00 or 4.000, and I can keep using as many zeros as I want. Now, that doesn't make sense to keep writing zeros, so we just write the number 4, okay? Now, on the right-hand side of the decimal, it follows the same exact naming convention. On the right-hand side of the decimal, you have tenths with a THS. So this THS tells me, okay, this is a decimal point, or it's to the right of the decimal point. So what do you think the next place value would be then? Hundredths. Very good. I'll write it above. Oh, forgot my D. And then the next one would be thousandths. And the next one would be 10,000ths. And so forth. It follows the same exact naming convention. Okay? Now, what I'm going to teach you how to do first is I'm going to teach you how to write in words a decimal, because there's something that we kind of say when we're doing this that isn't correct. All right, so for example here, I want somebody to read me this number. Can somebody read me that number?
I'll go.
Go for it.
4,103,000.
Very good. So this is the number, and I'm going to write it down. 4 million, comma, 103. Now, some of us, and you don't have to tell me if it was you or not, but maybe at least one of us in the room, when you saw that number, you read it as this: 4,103. Like you said the word and that is incorrect, because the word and, when you're reading numbers, means decimal point. Okay? So that's why, and even if we go, I think we did this all the way back in like chapter 1 in whole numbers. all the way back here. Let me see if I could find it here. Notice with this number, 547,003. And then I wrote it out in words directly underneath. Notice there's no and. There's no and there. And that's because and means a decimal point. So if we go back to our section now, and I write this, all right, this is actually the technical way to read this, or write it, would be 5 and 3/10. So the 5 represents the whole number. The and is going to be our decimal point. And the part that really kind of will trip us up is going to be the very last part, which is the decimal place. So whenever we're writing numbers, all right, you always just write what the number is, like 3. And then whatever position, whatever place value that 3 is located in, that's going to be the last word you write. So in this case, it's 5 3/10. All right? So another example of this would be something like, I don't want to use 3 again. We'll use 7. So here's another example. So the way I would approach this, I would write the whole number first. So that's going to be a 2. Then I write the word and. Now I'm going to write 17. But now I got to worry about the place value. So if you look at the 0, 1, 7, the 0 is in the tens position, the 1 is in the hundreds position, and then the 7 is in the thousandths position. So you would write 2 and 17 thousandths. Does that make sense? Now sometimes, and I'm going to be honest with you, I'm not perfect. I get lazy. And instead of me saying 2 and 17 thousandths, I say 2.017. Anybody else like me? It's okay. Asthma, I'm with you. We're in the same boat together. When we start really doing a bunch of examples with decimals, like adding, subtracting, multiplying, dividing, I get lazy. And I'm like, oh, this is 2.017. And I think the reason why I'm like that is because if I ever talk to somebody on the phone and I'm giving numbers, I usually give them one at a time. And now that I'm dealing with decimals, that like naturally kicks in. All right. So for now, just kind of know how to write them. But then once we really get into this, if I ask for an answer and the answer is 2.017 and that's what you say, I'm going to say, great, fine, thank you. Fantastic. All right. I'm not going to be the decimal police and yell at you because you didn't say it as 2 and 17 thousandths. All right. Where would being able to write out decimals and everything, where would that really kick in? Anybody know? There's only one place I can really think about where you got to be able to write a decimal. And some of you may have never done this. I do it 3 times a year. Todd just killed a fly.
It was in the way.
How many of you ever wrote a check? Better, let me ask the question this way. How many never wrote a check before? Look at that. The hands go up. That's scary. I feel so old. What really makes me feel old is this.
Well, wait, does that mean then that the time that you would use the decimal point is for when you would write a check and you would have to put the decimal point before the change part?
Yep. That's why the way we write a check is you always write and. Which I would imagine this is a very hot topic back in 1843 when checks were being used. I don't even know if they were being used. I'm just trying to be trying to be funny here. But that makes me feel old that there's a substantial amount of people in this room that never wrote a check. How about this? And this one really makes me feel old. How many of you actually went to a music store to buy one of your favorite band's new albums, whether it be on tape or CD? Autumn. Todd. That's it. I remember.
The closest I've been was people buying music from the exchange while I was with them.
But that's not a. I'm talking about like a Sam Goody. Like, I remember walking to the mall because one of my favorite bands at the time were coming out with a brand new album. And I'm like, oh, I'm going to the mall because I want to be the first one there to get that album. That was a big thing for like young people. Now it's all iTunes or Spotify. And I think I wait until you're a little older and you start having kids and they start growing up. You're going to be asking them the question, have you ever bought an album? Because now people don't even buy albums anymore. They buy songs. And if you really like it, maybe you buy the whole album. But let's be honest. Maybe you're not even buying songs anymore. You just subscribe to Spotify. Like me. I'm a big fan of Spotify. Autumn, times are changing. All right, let's continue. Now that we all know Professor Float is old. If you can guess my age, I'll give you a couple bonus points.
45.
No. Connor, you fail.
Oh.
Now I feel really old.
33.
How old?
40.
No.
38.
No.
35.
No.
30.
No.
32.
Can you give us a hint?
Yes, it's below 30.
21. Like.
No, it's actually above 30. I'm lying to you. I am 41.
41.
41 years old.
Okay.
I'm an old person.
You're older than my parents.
Thanks, Jasmine.
I was close.
Amber, you were very close. I can't believe you just said that, Jasmine. I feel super old now. Anyways, now I'm going to ask you to write the number in standard form. All right. So here we go. Oops. $500, 1, and $22 hundreds. I always forget to write that D. I'm older than Jasmine's parents.
If it makes you feel any better, you're younger than my parents.
Hey, there we go. I'm back to even Steven. Perfect. So we're going to write this number in standard form. And once again, this is just a matter of finding keywords. Like right here, the word and. We know the word and now means decimal point. So anything to the left is going to be the whole number. Anything to the right is going to be the decimal. So 501, that's easy. Then we have the word and. Now, this is the hard part. 22 hundredths. My suggestion to you would be to write out some dash marks. And then now you can see the place values. We know the first one is going to be the tenths. And the second one is going to be the hundredths. So all we need is 22 hundredths. So just fill it in. 22. We didn't even need this last place value, so we can erase it. All right. Are there any questions there? We're going to do one more like this, okay? $62 10,000ths. Now, in this situation, there is no whole number. That's why the word and is not there. However, we do see the THS ending on the number, or on the word. So I know this is a decimal. So I put a decimal. I'm going to write out some place values. And then you literally just go left to right and start naming them. Don't write numbers yet. Name them first. Tenths, hundreds, thousandths. Here's our 10,000ths right there. So I need 62 10,000. So I'm going to put a 62 because that 2 has to be in the last place value. So I put 62, and now for the tenths and the hundredths position, I just put zeros. And that gives me the proper spacing. Does that make sense so far, everybody? Okay? So there's the first thing, is just naming, going back and forth. Now the second thing I want to go over today is to convert a decimal into a fraction. All right? And once again, this all comes down to, do you understand place value? So in parentheses, I'm just going to put understand place value. All right, so here's our first example here. Let me show you how it works, and then I'll give you some steps. So we have 4 and 9 hundredths. Now, think about what I just said. 4 and 9 hundredths. We know the 4 is a whole number, and if we're converting into a fraction, that 4 is going to be the 4 of a mixed number. So that's the whole number. Now you got to worry about the decimal part. But since this is all about understanding place value, that 9 is in the hundreds position. So you would write 9 over 100. The only thing you got to check is my fraction simplified? For us, the answer is yes. Okay? So there's the first one. Here's another example. Let's make it just 3.7. Or 3 and 7/10. So since I said the word tenths, this is going to be 3 and 7 over 10. All right, and that's reduced. Are there any other questions so far? All right, let's do one more where we got to reduce it now. How about -5 and 25 hundredths? Well, that negative just comes along for the ride. So we have a whole number of -5, and then the fraction is 25 hundredths. So we're going to write 25 over 100. And now we need to reduce. So remember, there are plenty of ways to do this. You got one foolproof way, which is prime factorization. So 25 is 5 times 5. 100 is 2 times 2 times 5 times 5. We can reduce the 5s. They turn into a 1. So -5 and 25 over 100 simplifies into -5 and 1/4. Does that make sense, everyone? All right. 2 more things in this section, and then we're going to move on. So the third thing is going to be comparing decimals, and that's really easy. Okay? So to compare decimals, we're going to start on the left and move to the right. So I think if I show you an example that'll make more sense. So here we have two decimals, 0.3148 and 0.3142. Now our goal is to use less than or greater than to make a true statement. So here's how you compare decimals. You start on the left and you move to the right and you just compare. So on the far left, for each number, there's a 3. Since they're the same, I move to the right. They're both 1s. They're the same, I move to the right. The next number are both 4s, so I move to the right. And lastly, I have an 8 and a 2. Since 8 is larger than 2, 0.3148 is going to be larger than 0.3142. All right, does that make sense? Okay. Now there is a tricky one. We do got to be careful. All right, and it has to deal with, well, what if you have negatives? Okay, what if you have negatives? All right. And like I said, this is a little tricky, okay? And it's because of the location of where they are. All right? So I think what we need to do first is go back and look at just comparing negative numbers first. So if I look at this example, -4 and -8, we know -4 is greater than -8. And the reason for that is on a number line, -4 is further to the right when you're comparing it to -8. Does that make sense, everyone? Okay? So as long as you can remember that, when you compare decimals, it follows the same trend. Okay? So sometimes, and I've seen this a bunch of different ways, but sometimes people just say, okay, well, if we look at this, -0.42, we compare the 4s, they're the same. We compare the 2s, and they're the same. So -0.42 is greater than -0.46 because it's further to the right on a number line. So that's one way I've seen people do this, which is just being able to understand where they are placed on a number line. The other way I've seen it, which I don't know if I'm a big fan of, but it is what it is taking the absolute values of each and then saying, well, since 0.42 is less than 0.46 when you take the absolute value, and remember, absolute values are positive numbers. Since we have negatives, it's the exact opposite now. So even though when you take the absolute value, it's negative, when you go backwards, you go the opposite way, so now it's positive. All right? It's up to you which way you want to do it. For me, it's not a big deal. Any questions so far? All right, good. We are moving at a comfortable pace. Unless you think I'm moving too fast.
I have a question, please.
Go ahead, Asma.
Teacher, what if we have one number? If we have a number before the point.
Okay, so you want to see an example like, do you want them negative or positive, or it doesn't matter?
Doesn't matter.
All right. So what about something like this? Am I right?
Yes.
So start on the far left. They're both number 4s. Move to the right. Same thing. They're both number 1s. Move to the right. They're both numbers 2s. Now, if you move to the right here, as I said earlier, there's a 0 there. You can keep writing as many zeros as you want in a decimal. So that's a 0, but that's a 3. 0 is definitely less than 3. So you would just write less than.
Thank you.
You're welcome. Good question, by the way. So the last thing I want to talk about in this section, it's supposed to be a Roman numeral 4. It's just rounding decimals. Now, rounding decimals is the same exact thing as what we learned all the way back in chapter 1 when you were rounding numbers. Step 1, underline the place value being rounded. Step 2, draw the arrow. So draw arrow to the right. And then step 3, make your decision. Remember, 5 or more, round up. 4 or less, stays the same. Now, if you went back into chapter 1 where we learned about rounding, right? When you round whole numbers, after you make your decision, you're supposed to write zeros afterwards. But with a decimal, we know there's an infinite amount of zeros to the right, so we don't even have to worry about writing them. So let me show you what I mean here. So we're gonna round 18.9925 to the following. First, let's do the nearest thousandth. So what I do is I just rewrite the number. And I follow my steps. Step 1, underline the place value that's being rounded. Well, since it's the thousandth, it's going to be the 2. I look to the right. I draw my arrow. That's step 2. Now I need to make a decision. Well, that 8 is larger than 5, so I know I'm going to round up. So this turns into 18.993. Notice I don't have to worry about the zeros afterwards because technically there's an infinite amount of them. Now part B. Oh, I'm writing out the number without the directions. If I want to round this to the nearest tenth, I write the number again. I underline the place value in question. So the first 9 is the tenths position. I look to the right. That is a 9, so I know I'm going to round up. But if I round up, that 9 has to turn into a 10. So if you think about it, that 9 is going to turn into a 0, and then you carry the 1 over into the ones position. So it's going to be 19.0. Does that make sense so far, everyone? All right. And the last one, I might as well do this. Round to the nearest hundredth. Well, like always, I rewrite the number. I underline the second 9 because that's the 100th position. I look to the right. That's a 2, and that's definitely smaller than 4. So the 9 stays the same. 18.99. Good? All right. So there's like our crash course introduction on decimals, okay? Now I want to transition into section 2, which deals with decimal operations. So let me type in section 2. And honestly, I can sum up this entire section with these 2 words. Just stay organized. Just stay organized. The first three operations I think are the easiest. Add, subtract, and multiply. Very straightforward. It's dividing decimals that always gives us a little bit of problems, and I think it's just because we forget that we need to stay organized. So the first one I want to do would be adding, okay? And the key to this is just to align the decimals. That's it. Okay? So, for example, let's say I want to add the following two. 5.98 plus 0.031. All I have to do is align the decimal. And notice all my place values are nice and organized. Now, within the 5.98 number, if you wanted to, wherever you see like an open spot, you could put a 0 there if you wanted. That's fine. You could put a 0 there. In fact, underneath the 5, we could put a 0 as well. But the key to this is keeping everything all lined up. So now everything's lined up based off place value. I put a decimal in my answer and I just add. 0 plus 1 is 1. 8 and 3 is 11. Carry the 1. 9 plus 0 is 0 plus 1 more is 10. So put a 0 and carry it. 1 plus 5 is 6. Any questions there? All right. I don't think I need to do any more examples with adding. I think one example was good enough, which is just keep everything nice and organized. Part 2, subtraction. Same thing. If you align your decimals, this is easy. So let's try the first one. It's very straightforward. Oops. $25.98 minus 1.31. So I just try to write as neat as possible. And I just subtract. Put my decimal first. 8 minus 1 is 7. 7 minus 3 is 4. The decimals are already lined up. 5 minus 1 is 4. 2 minus 0 is 2. So 24.47. Okay?
Professor, did you mean to write 98 instead of 70?
Oh, I wrote down the wrong number, didn't I? We could fix that real quick, Todd. How about 24.67? Sorry, I just wrote down the wrong number. The only time this gets a little, I guess, difficult is with this example right here. $50 minus 2.814. Okay? And the reason why is because it looks like that 50 doesn't even have a decimal point. But it does. All whole numbers have a decimal point on the far right side. So even though we didn't write the decimal point, 50 is really 50.000, and you can do as many zeros as you want. You can keep writing as many zeros as you want. But in this specific situation, I'm only going to write 3. And the reason why is because in my second number, I only have 3 decimal places. So now that everything's aligned, put the decimal in your answer, and now you just subtract. And here, we're going to use, we got to borrow, just like you would back in chapter 1. So the 0 turns into a 10. All of these zeros turn into a 9. And the 5 turns into a 4. So 10 minus 4 is 6. 9 minus 1 is 8. 9 minus 8 is 1. 9 minus 2 is 7. And 4 minus 0 is 4. Any questions with that? Maria Gunther, you good? I'm just gonna call you Maria G. I think that's Maria G sounds like like somebody really famous. Like, oh, it's Maria G over there. Don't go talk to that person. She's eating right now. You don't want to bother a famous person when they're eating. Sound good? Maria G, did you eat breakfast yet?
Not yet. I did make ramen noodles though, and I still haven't eaten them yet.
All right. Well, let's finish this up then so you can eat. I got a bagel to my right, and I can't wait to devour it. So here we go. Hence, now you know why the dog got into the butter, because I left the butter out. So there you go. There's the complete circle. It all comes around. So the last thing I want to go over is multiplying decimals, okay? And what I'm going to do is I'm going to give you the steps first, and then I'm going to show you a couple problems on how we actually apply them. So step 1. All you got to do is multiply. In other words, you don't have to align the decimals. I don't say align them, so don't worry about it. Just multiply. Step 2. I want you to count the total number of decimal places in each number. And then step 3, within your answer, you're going to start on the far right side. Move the decimal. Move the decimal point to the left. The same number as step 2. All right, so here's an example. We have 3.21 times 1.2. So, step 1, just multiply. Notice my decimal place is not aligned, and I don't care, because according to my steps, it says multiply. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. Now I drop down a 0. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. Now I add 2, 5, 8, and 3. Finally, step 1 is done. It's the longest step. Step 2, we're going to count the total number of decimal places in each number. In the first number, you have 2, because that's 21 hundredths. So you have 2 decimal places. In the second number, you have 1. And when you total them up, that gives you a total of 3 decimal places. That is the same number of times you're going to need to move the decimal in step 3. So starting on the far right side of the number, place a decimal, and then move it to the left 3 spots. 1, 2, 3. So 3.21 times 1.2 is going to equal 3.852. Does that make sense? That's as easy as, that's as hard and as easy as it gets. All you got to know are those 3 steps. Remember, that's what I test you on. I can give you a limitless amount of problems with multiplying decimals. If you know the 3 steps, doesn't matter what numbers I give you, you know how to do it. Okay? Let's try one more before class is over. So we're going to multiply 0.03 times 0.045. Okay? So remember, order doesn't matter when you multiply. 4 times 5 is 20. 5 times 4 is 20. Order doesn't matter. So what I'm going to do is I'm going to put 0.45 up top, 0.03 down below, and I'm just going to multiply. 3 times 5 is 15. Carry the 1. 3 times 4 is 12. Plus 1 more is 13. Now, I don't have to worry about multiplying by 0 because 0 times anything is 0. So step 1 is done. Step 2. There are 3 decimal places in the first number. There are 2 decimal places in the second number. So that's going to be a total of 5. Step 3. In my answer, I place a decimal on the far right side, and I move it to the left 5 times. So 1, 2, 3, 4, and 5. Now, Maria G, I asked earlier what they had for breakfast. Because when I look at this, I think of my favorite breakfast, which is eggs. Doesn't this little loopy loop thing at the bottom, doesn't it kind of look like the bottom of an egg crate? Fill it in with eggs then. So 0.03 times 0.045 is going to be 0.00135. And that's your answer. Okay? Are there any questions? All right then, good. Well, I'm going to stop recording. I'm going to call it